No, sir. The balance. I didn't
Hmm?
complete. Yeah, I
What?
couldn't complete. I couldn't finish
Okay,
it.
okay, okay. Do it, do it.
Mhm. No, sir. Could you do it? I'll do this.
You are not able to solve by yourself. Can I
Yeah, I
solve
forgot
this?
this. Yes, yes.
Okay, okay. See, See what we have done. So just let's recall all the topics that we have done in the last class. So we have started the chapter chemical kinetics, and this is the chapter. This is the branch of physical chemistry in which we are basically dealing with what? We are basically dealing with the rate of a reaction. Okay, and rate of a reaction means that in how many time in
Yeah.
how much time that a reaction can take to complete. Understood? So there are then we have classified
Understood.
the rate of reaction on the basis of its a duration of completion. Like for example,
Speed.
we are if we discuss about a very
Yes.
fast reaction. So this type of reactions are those reaction in which the time in duration is very less. Like for example, 10 to the power minus 14 or 10 to the power minus 16. So it's like instantaneous time duration. Like it's less than 1 second. So we are not able to calculate, or we are not able to analyze, or able to solve the questions on this, because the time duration is very less, and we are not able to observe the changes that is happening in the product or the reactant. Fine. And the next is your very slow reaction. Very slow reactions are those reactions which will take a very large number of time. The duration is very large. For example, it'll take 2, 3 days, 4 days, or it'll take months to complete. Then a months or year. For example, the rusting, the fermentation, the formation of water and temperature. So these are the examples of the very slow reaction. And then we are then the next type is my moderate reactions. Moderate reactions are those reactions in which the time is measurable, in which the rate is measurable. Basically, the how my product is disappearing, and how my sorry the product is forming, and how my reactant is disappearing. This rate we can easily find it. These are the measurable rates. So we are more concerned with the moderate rate of reaction. And then the examples are like this. This is the like you have the alkaline hydrolysis of is ethyl acetate. This is the ethyl acetate, and if we react the acetate with a base, a strong base, then this reaction will happen. Basically, we are doing the hydrolysis, and this is the reaction which comes under what? It comes under the moderate rate of reactions, and moderate rate of reactions are those
Yes.
which will take significant time, and we can measure the changes that is happening. So now, on the basis of the changes, we have discussed this question based on the duration. You can solve this by your own. So this is the first thing that we have discussed. This is the first and the most important topic. This is the rate of a chemical reaction. So how can I write a rate of a chemical reaction? So for example, I'm having like I'm going to the page that where it is written. So see, this is rate of a reaction. Just 1 second. Just 1 second. Um, where it is. Just one. Give me 1 second. See, okay, fine. So what I was telling you is ki I'm having I'm having a rate of a reaction. So in this rate of a reaction, what is happening? Like for example, this is the general chemical equation. Alpha A, beta B gives gamma C and delta D. So if I want to write a
Hmm.
rate of a reaction, so the basic rules are, first, if we are talking about the reactant. So at the reactant side, we know that the final reactant which is left after the completion of a reaction is lesser than the reactant which is there, which is present at the initial point. For example, I am having 10 grams of let's say A. 10 grams of A. I'm having 10 gram of A. And after some time, this will the some amount of reactant is disappeared. For example, like 2 gram is disappeared after time t. Okay. So if the 2 gram is disappeared from 10
Okay.
gram of a react, then how much gram will be left? The 8 grams will be left. Okay. And this 8 gram is lesser than the initial grams which is there, which is the 10 gram. So what is happening at the reactant side? My final reactant is lesser than the initial. Okay. So we know that the rate should be positive, because if we are defining the rate of
Yeah.
anything, it should be in a positive terms. So in order to make this rate positive, what we need to do, we just need to multiply this with a negative sign. We have to multiply the change of a rate, change of a concentration. So this is the change in the concentration, like final concentration minus initial concentration. This will comes up to negative. So in order to neglect this negative, you can apply the mod sign here, or if mod sign is not there, just multiply this by minus, so that it'll neglify the negative term. Okay, and then divide
Okay.
this with the delta t. So this is the rate, in how much duration the concentration will changes. Now it is the disappearance, rate of disappearance. But when it comes to rate of a reaction, if I am talking about what is the rate of a reaction, then this is the different thing. The rate of disappearance, rate of appearance, rate of formation is different than the rate of reaction. Rate of reaction is basically the change in the concentration with respect to the stoichiometry which is associated with it. For example, this is the reactant, and A having the coefficient alpha, B having the coefficient beta, and these are the reactants. So if we are classifying a rate of a reaction, then the rate is basically with respect to the coefficient which is associated with it, like delta B upon delta T divided by beta. So this is the beta. Beta is the coefficient, and this coefficient is associated with the what? With the stoichiometric thing which is there in the reaction. Understood? So if you want to write a rate of a
Okay.
reaction, so the rate of a reaction is basically the change in the concentration with respect to the coefficient. But if we are talking about rate of disappearance, rate of appearance, then just we have to write the rate. For example, change in concentration divided by delta T. Understood?
Yeah.
Now move on to the question that I have given you. So the question is this. This is the question, which is ammonia reacted with the oxygen. It will gives to nitroso plus H2O. Take not nitroso, nitrogen oxide. Okay, so see here, it is nitrogen monoxide. See, this is NH3. So NH3, I have to first balance the chemical reaction. So in order to balance the chemical reaction, how this reaction gonna balance out? So first balanced out the nitrogen. So nitrogen is already balanced. One nitrogen is here,
Yes.
one nitrogen is there, it is balanced. Then see number of hydrogens. So here three hydrogens are there, two hydrogens are there. That means we need to balance the hydrogen. In order to balance the hydrogen, what need to do? You just need to multiply here
Multiply
by 2
two.
and here by 3. So that it'll six hydrogen, and here 6 hydrogen. So 6 hydrogen is equals to the 6 hydrogen. But if you see the nitrogen, two nitrogens are here, here only one nitrogen. So here I have to multiply this by 2, so that the nitrogen is also balanced out in
Two.
the reaction side and the product side. So the two nitrogens are there in the reactant side, two nitrogens are there in the product side. And if you calculate the number of hydrogens, so 6 hydrogens are there in the reactant side, 6 hydrogens are there in the product side. Now, this is the oxygen. This is the oxygen. How
Yes.
many oxygens are there? Two oxygens are there.
Two.
If you see here, how many oxygens are there? 2 and 3. It will be 5. So
Five.
what I need to do? I just multiply this by 5 by 2. But you know that a chemical reaction is to be in proper whole number stoichiometric ratio. So for that, I need to multiply the whole reaction with 2, so that the fraction part will be cancelled out. So here 4NH3 plus 5O2 gives you 4NO plus 6H2O. Now if you see, the whole chemical reaction is balanced out. 4 nitrogens are there, 4 nitrogens are there. 12 hydrogens are there. See, 12 hydrogens are there. 10 oxygens are here. And 4 and plus 6, 10 oxygens are there. So now the reaction is balanced out. Now you have to write the rate of a reaction. How are you gonna write the rate of a reaction? Just apply the formula, rate of change of reactant with respect to, or the product with respect to the stoichiometry associated with it. So delta NH3, concentration of NH3, change in concentration of NH3 divided by delta T divided by 4 with the negative sign. Why? Because it is reactant. Minus delta, change in concentration of the oxygen, divided by delta T divided by 5. Why? Because it is 5 is the stoichiometry which is associated with oxygen. Now for the nitrogen monoxide. Nitrogen monoxide, change in concentration of nitrogen monoxide with respect to delta T and divided by 4. And why we are not applying negative sign here? Can you tell me?
On the product side.
Because it is at the product side. Correct. Good. Now this is the rate of a chemical reaction, rate of a reaction. Now what you need to do? Just collect the things which is there in your question. So in the question, what is
Question.
written? in the question, it is written that the concentration of NH3 changes from this to this. So the change in concentration is given to me. So the initial concentration NH3, initial concentration of NH3 is my 0.68, and I know that it is a reactant. That means the final concentration is to be lesser than the initial. So the final concentration is my 0.34. Understood? 0.68, 0.34.
Yeah.
This is the final concentration. This is the initial concentration. Now, what is there? The how many time it will take to change the concentration? It will take 10 seconds. So the change in change in concentration, how much time? 10 seconds. It will take 10 seconds. Now, what is asked to me? It is in the question. The question asks me about appearance of NO. So for the appearance of NO, what you need to find? See, go to the NO wala part, and if you see here, this is the NO. So this is the thing that you need to
Yeah.
find.
Yes.
Okay. So what is the thing which is given to you? This thing is given to you. So just equate these two things. That's it. You're done with your question. So this is the concept, like change in concentration. So change in, if I want to write the change in concentration, what is the change in concentration? It will be 8 minus 4, it will be 4, and this will be 3.34 is the change in concentration divided by 4 and divided by time. How much time? T seconds. Okay. Now what you need to find? Delta NO, concentration of NO, divided by delta T, delta 4. 4 and 4 gonna cancel out, and your answer would be 0.034. What? This should be in molar per second. Got it? This is how you have to
Yes.
solve the questions of rate of a reaction. So this is the thing that we have done in the last class. Okay. So I have revised the whole
Okay.
topic that we have discussed in just like 10 minutes. Now just move on to the next topic, and the next topic is my rate law. And this is one of the most important topics that is there in this chapter. So rate law and rate constant. What is rate law and rate constant? I'll tell you. So you see the definition. So law of mass action is the first thing which is there in the rate law. Law of mass action, and this is the one of the most important thing that is there. What is law of mass action? So basically, according to it, the rate of a reaction is directly proportional to the multiplication of the active masses. What do you mean by the active masses? Basically, the active masses are those masses which is the concentration. Active masses is basically the concentration of a reactant. For example, if I ask you, this is like, for example, I'm given you the reaction. This is the general reaction. This is the general reaction. And if I ask you what is the active mass of A, so the active mass of A is its concentration. Its concentration is the active mass. If I ask you what is the active mass of B, so the concentration in molarity is the active mass of B. So this is the active mass. Okay. So it is basically the multiplication of the active masses of the reactant raised to the power equals to the stoichiometric coefficient. So this is the most important point that I have to address here. What is the thing? If you see carefully, okay, mark my words, what I am, repeating again and again, it is basically the multiplication of the concentration raised to the power of their stoichiometry. It is basically raised to the power equals to the stoichiometric coefficient which is associated with the respective reactant. And we are not discussing about the product. We are basically concerned with the reactant wala part, not the product wala part. We are concerned with the reactant. So basically, if I want to write a rate of a reaction from the active masses with the help of the active masses, so how can I write? So basically, what we have read in the last class, we have read again the rate law, and now we are also studying the rate law. What is the difference between the rate law which we have discussed in the last class and this one? So basically, this is not the rate law. This is the active mass, law of active mass. This is the law of active mass. And through this law of active mass, I can derive my rate. Okay. So there are many ways to write a rate of a reaction. Okay. So the first way that how I can write a rate of reaction is the definition of it. For example, the concentration, change in concentration with respect to time. This is the definition. By the definition, the rate law is defined. Now, by this thing, the rate is defined. Now, from the rate law, how I can write a rate of a reaction. So this is basically the concentration, multiplication of the concentration of the reactants raised to the power of the stoichiometry associated with the respective reactants. Understood? Like I'm writing the rate here. R is basically directly proportional to the concentration of A to the power alpha, concentration of B to the power beta. Understood? Now, if I remove this
Okay.
proportionality sign, I'll end up getting the constant, and the constant is k, and this constant
Constant.
is your k raised to the power of alpha raised to the power of beta. So this is again the rate. This is again the rate of a reaction, and this one is also the rate of a reaction. Change in concentration of A divided by change in concentration of D divided by alpha. So this is also the rate. This is also rate. This is also rate. Rate of a reaction. Rate of a reaction. I can
Mm,
easily equate these two rates. This rate is defined from the active mass, law of active mass, and this rate is basically by the definition. I can easily, equate these two rates. Why? Because these are the equal. This is the rate of a reaction. I can equate these things. Okay, so for example, like I'm having the example of this reaction, which is my 2a plus b. If you see here, 2a plus b, it'll give me the product. So if you see here, r is basically directly proportional to a to the power 2, b to the power 1. Why? Because b is having a coefficient 1, 2 is having a coefficient of 2. So if you see here, r is
Two.
basically directly proportional to concentration of a raised to the power of 2 to b raised to the power of 1. Understood this thing?
No, could
Hmm?
you repeat that?
What?
Could you repeat that? Could you
Okay,
repeat it?
what I was telling is that key I am defining a rate of a reaction. For rate of a reaction, the definition is that through the law of active mass. What a law of active mass says, it says that key it is just nothing but a multiplication of the active masses. And what are the active masses? The active masses are the concentration of the reactants. Basically, multiplication of the active masses or multiplication of the reactant, concentration of a reactant raised to the power of stoichiometry, which is associated with it. And what is the stoichiometry? Here, if you see, alpha is the stoichiometry. And if you see here, 2 is the stoichiometry, 2a. So raised to the power of 2, raised to the power of 1. So this is how I can define a rate. Understood now or not? And this is the theoretical concept, not a practical concept. This is the
Okay.
theoretical, imaginary, ideal concept.
Yeah,
Understood?
understood. Understood. Mm,
Can I move forward?
yes.
Okay. Just a second. Okay, this is done. This is done. So this is my rate law expression. See, if you see carefully here, see it is rate law expression. What is rate law expression? What is rate law expression? According to it, the rate of a reaction is directly proportional to multiplication of the active masses. This thing is same, which is there in
Yes.
this law of mass action. Okay, law of mass action also says that according to it, the rate of a reaction is directly proportional to the multiplication of the active masses. This thing is same in both the cases. If you see here, it is basically directly proportional to the multiplication of the active masses. Everything is fine. Of the reactant. Here also we are discussing of the reactant. So basically reactant is there. We are not discussing, we are not concerned with the product. With each term raised to the power of some, raised to some power. This is the point that I have to make here. This is the point raised to some power. But what, according to law of active mass, in that part, what is written? It is written that it is raised to the power of stoichiometry. But rate law expression says that it is not equals to the stoichiometry. It is having some power which can equal, which may be equal to the stoichiometry, may not be. It depends on the reaction, that how the reaction will proceed. Are you getting my point? What I was trying to say. There are
Yeah.
two laws that I have discussed here. The first one is
Yes.
law of mass action, and the second thing is rate of a reaction. Rate law expression. Rate law expression. Rate law expression. So according to law of active mass, what is written here? According to a law of active mass, it is written that ki R is directly proportional to concentration of the products, concentration of the reactants, not the product, sorry, concentration of the reactant raised to the power of this stoichiometry. But according to law of active mass, rate law of expression, what is written? It is that ki R is directly proportional to A to some power. To some power. Let's say A, let's say X, let's say Y. It does not depends upon the stoichiometry. Like for in both the cases, the chemical reaction would be same. This is the theoretical concept. This is the ideal theoretical concept. And this is not the ideal theoretical, this is the practical concept. Okay, this is the practical concept. Understood? This is the experimental concept. Understood or not? And X and Y may or may not be equal to stoichiometry. It depends on the question. May and may not is very important. Understanding? Are you getting my point?
Which one
Elisha?
was may? Which one was may or may not?
What?
Yeah, which was the may or may not? I couldn't hear.
May and may not is raised to the power of stoichiometry. See, alpha and beta are the stoichiometric coefficient. So may and may not means that it may be equals to and may not be equals to. Depends on the reaction.
Okay.
Like depends on the condition, how the condition is there. I'll tell you the conditions and then after you can write by your own self that it is equal or not. It depends. It is not, it is not, very constructed about ki we have to put the power which is there in the stoichiometry. This is not the thing. It may and may not. It depends.
Okay.
Understood?
Yeah. Yes.
बोलो.
Yes.
Elisha,
Yeah. Yes. Yes. I do.
understood or not?
Yes. I understood.
Okay. Just give me 1 second. My PPT is not responding. If you have any doubt, you can ask me.
Yeah.
Do you have any doubt?
No, I understood.
Okay. See, now the next topic is we are going to discuss about rate constant, the K. Okay. So basically it is specific reaction rate, or you can say it as a rate constant. And it is if the concentration of all the reactant is taken to unity. Basically A and B becomes equals to, it will equals to 1. When the alpha A and B equals to 1, the concentration equals to 1 molar, then the rate of a reaction is equals to the rate constant. That's it. This is the thing. Understood or not?
Yeah, understood. I understood.
So if you have any doubt in any of the cases, like what is the mass law of mass action or rate law expression, you can tell me if you have any doubt. Do you have any doubt?
Yeah, no, no, it's okay.
Okay, fine. Let's move on to the next topic, that is molarity of a reaction. Molecularity of a reaction. What do you understand by the molecularity of a reaction? Do you heard about this term? What is molecularity? Any idea
No.
about molecularity? No? Okay. So basically, it is the total number of reactant molecules which collides simultaneously to bring about the chemical change. It is known as the molecularity of a reaction. So basically, in simple words, what is written here? For example, I am having A and B as my reactants. This is my reactant. This is what? This is my reactants. And they combines to form product like C. This is the product. Okay. Now, how the formation of product takes place. So, in any chemical reaction, what will happens? In any type of chemical reaction, there are the reactants which is there. They basically collides to each other, and depending upon the type of a collision, the product will forms. Why? Because there is some energy gap. There is certain energy barrier which is there, and if the energy barrier is breaks up, then the product formation takes place. Why I'm saying that? Because if two reactant, like for example, this in this hand I'm having A as a reactant, in this hand I'm having B as a reactant, and they both collides, but the perfect collision is not happened. Then if the perfect collision has not happened, like they just touched and passed on, the product is not formed. Why? Because the energy that has to be generated in that reaction is not generated. So if the energy barrier is not break up, then the product will not gonna form. But if the collision will happen, like if the collision is perfectly elastic collision, like head-on collision, they just come like this and just collides with each other. Understood? So if the perfect
Yeah.
collision happens,
Yeah.
then they bring out the chemical change and the product formation takes place. So it's basically depends on how the collision is happened. So what is written here is in if I am telling you about the molecularity of any chemical reaction, then basically the molecularity is a topic which is a theoretical topic. It is a topic which is a theoretical topic, and basically what happens in that key the collision will happens, and if the collision will happens, the chemical changes will takes place. And if the chemical changes will takes place, then the molecularity of a reaction would be depending upon how many molecules or how many reactants are there. For example, if three molecules will collide to each other and form a product, then the molecularity will be 3. And if the two reactants will collide to form a product, then the molecularity will be 2. Understood? So basically it is a
Yeah.
theoretical concept, and it is the number of reactants. It is basically the total number of reactants that collides simultaneously to bring out the chemical change. It is known as the molecularity of a
Chemical
reaction.
change.
It is theoretical concept. It cannot be negative, zero, or in fraction, and cannot exceeds 3. It means that the molecularity is not going to be more than 3. Why? Because at a particular instant, at any instant, the four molecules are not going to be collide with each other. It has to be 3. Why? Because this is the maximum limit at which a energy barrier is going to be
Mhm.
break up. Okay, we have to collide the reactants perfectly so that the chemical reaction will takes place. So for that, the maximum molecularity that can any reaction will have is 3. This is the maximum molecularity. Okay. And
Reaction.
what are the
Okay.
conditions? It will never be negative, it will never be 0, it will never in fraction. Never be negative, never be 0, never be in fractions. Why? Because
Be
can you
fraction.
guess ki half of the A collides with B? This is not the practical thing that half of the molecule is going to going to collide with the other reactant molecules. It is not practically possible. Okay, so that's why it is not negative. It's not be 0. It not be in a fraction. It'll be in a simple natural numbers, and it will not going to exceed 3. Understood? Bolo,
Yeah,
if you have
understood.
any doubt, you can ask me. Huh?
Like, why does it not exceed 3?
Because
Why does it
if
not exceed 3?
if the reactant molecules are more than 3, then the perfect collision is not happened perfectly. Like perfect, simple, elastic, perfect head-on
Okay.
collision will not never gonna happen if the molecule exceeds 4 or 3. So that's why it will maximum to maximum it will be 3, not more than 3. Okay? Understood or not?
Yeah, understood. Okay.
Fine. Now the next topic is my like if I'm having a multi-step reaction, then how can I define a molecularity of a multi-step reaction? So just write the multi-step. I am just writing that how this will happen. So just write with me what I'm writing. So the topic is multi molecularity of multi-step reaction. So before multi-step, I'm having molecularity of a single step reaction. Okay. So for a single step reaction, how a molecularity is defined? Just based on the number of reactant molecules which is there. Okay. So it is basically the total. I'm just writing the definition. So it is basically the number of total number of reactant total number of reactant molecules total number of reactant molecules involved in balance stoichiometric stoichio balanced stoichiometric reaction is known as molecularity of a single step. Okay. And if I'm having multi-step, then what is the condition? So examples are like, for example, I'm having PCl5
Okay.
reacts with PCl3. It'll guess, it'll guess you PCl2 and 2HI reacts with H2. Then it'll form this SO2, O2, and it forms this. So can you tell me what is the molecularity in different conditions? Like you are having three examples. Just tell me what is the molecularity of these different reactions. Just count the number of reactant molecules and just tell me the answer.
So first one is 2.
Huh?
The first one is 1.
What?
Is
First
the
one
first
is
one 1? 1.
1. True. So it is unimolecular. So if the molecularity equals to 1, it means that it is unimolecular. For second,
Also 1.
huh?
1.
No, 2.
2, because okay.
2 HI are there. That means the molecularity is 2. So
Okay.
it will be what? Bimolecular. And what is the molecularity in third case?
3.
Yes, it will be trimolecular. Now see, if the reaction is if the molecularity is in a multi-step reaction. See, the molecularity is the meaningless for multi-step reaction. Okay. Highlight this point. In a multi-step reaction, the molecularity concept is meaningless for multi-step reaction. If I'm having a multi-step reaction, then this is meaningless. Why? Because
Mm.
if I'm having a multi-step reaction, that means that in that multi-step reaction, I'm having some sort of reactions which is more than, like, if you see here, this is the reaction, and in this reaction, two steps are there, more than one steps are there. That means this reaction is taking more than one step to complete. So in the particular step, the molecularity is defined. So for if you see here in step one, the reaction is this reaction is happening. So if this reaction is happening, it means that in that case, I can define the molecularity. That key in step one, the molecularity is this, and in step two, the molecularity is. If you see here, the molecularity is 2 in this step. And if you see in this step, what is the molecularity? Again 2. Why? Because I am having two molecules. But if I ask you what is the molecularity of this reaction, so this is the reaction which is a multi-step reaction. In that reaction,
Multi-step.
in this reaction, there are two steps which is involved. and the two steps are here, which is written under it. The first one is this, second one is this is the mechanism of the reaction. And if you see here, so in a multi-step reaction, the molecularity is basically, I can write a molecularity of a RDS. And what do you mean by the RDS? RDS, the full form of RDS is the rate determining step. RDS. And RDS is basically the determining rate determining step. What is the full form of RDS? It is rate determining
Rate determining
step.
step.
Okay. Now, again, the next example. The next example is basically this. 2NO2, F2, and if you see here 2NO2F. So what is the molecularity of this reaction? So if you see, the molecularity of this reaction would be 2 and 3. 3 is the molecularity of this reaction. Am I correct?
No,
Two molecules and one molecule of F2. So
no,
molecularity, correct?
no multi. It's multi-step, so it's not.
Ah, correct. So this is the point that I have to make. Yes. Now you are correct. The molecularity is not 3 here. Why? Because this is the reaction having multi steps. And if a reaction having multi steps, it means that the molecularity is not defined, which is there, which is if you, the reaction which you will see directly. So the steps that are involving here is two steps. So the one step is RDS, which is the rate determining step. Rate determining step is that the step which determines the rate of the whole reaction. Like for example, I'm having two molecules. Like for example, I'll give you the example. Like see, this is me and this is my brother. Okay, and we have to go somewhere through a vehicle. Understood? We have to go somewhere through a vehicle. So I just go in my vehicle and I'm a driver. Okay, I have to drive a car. I'm having a car. So if I want to leave from a particular destination to the point that I have to reach there. So from here I have to start my car when my brother comes up into the car, and then we can go together. Okay. So
Yes.
if anyone who takes more time to come in that car will defines the rate at which we have to go. At what time we have to go? Like for example, the time is 10 a.m. We have to go somewhere at 10 a.m. But what will happen? My brother comes up to 12 p.m. So I have to drive a car. I have to start a car at 12 a.m. So who is determining the rate? The one who is very
Mm.
lazy, or I can say that slow. So same here. If any step is very slow, it means that this determines the rate of any chemical reaction. So if
Mm.
I'm having two steps, and in the two step, the step which is very slow defines the rate. Understood?
Yes.
So this step is known as your rate determining step, RDS. And I can write the molecularity of that step. And this is the molecularity of whole reaction. So the molecularity is 1 and 1, 2. So in that step, the molecularity is 2. It means that the whole reaction will having molecularity of 2. But this molecularity you have to write when it asks you in a multiple choice questions, like you are having the choices which are like 1, 2, 3, 4. So then you have to tick mark on a two option. But if it is it is a it is a question of it is a subjective question, then you have to write that in a multi-step reaction the molecularity is not defined. But if you ask key what is the, if you want to consider, however, then what you have to write, you have to write that key the molecularity is basically we have to define of a reaction which is a very slow reaction, the rate determining step. Understood?
Okay. Understood.
Bolo.
Yeah, understood.
Correct. So this is just give me 1 minute. Okay, just 1 minute. Hello, hello, am I audible?
Yes, sir.
Actually, there are some guests which is there in my house, so they are just going. So that's why I put it my uh,
Oh,
voice off because there is a lot of noise.
okay.
Yeah. Okay. See, so what I was telling
Okay.
you is that the molecularity of a multi-step is basically depends on the RTS. Understood?
Yes.
Now, let's move on to the next topic, which is order of a reaction. This is the one of the most important topics. Order of a reaction. So, what is order of a reaction? How I can define order of a reaction? It is basically the summation of the powers of all the reactant molecules. So, basically, if you add the powers, for example, I am having a chemical reaction like this. This is the chemical reaction, delta D. And if I have to write the, through the rate law expression, if I have to write the rate of these reactants, so let's say this is alpha, K alpha, P beta. Okay. So if I want to write the order of a reaction, then the order of reaction is basically alpha plus beta. Okay. It is basically alpha plus beta. And again, I'm telling you
Okay.
the alpha and beta are dependent on the reaction conditions of the reactions. Okay. It will not just key if you see the stoichiometry and just put the power at here. So this is not the rate law expression. Okay. This is the rate law expression because at this point I'm telling you. Okay. So if it is given from the examiner side, it's okay. But if it was not given, then it may and may not be equal. You have to find whether it would be equal or not. So it is basically the sum of the powers of the reactant
Okay.
molecules, and it is basically in a rate law expression. So what is the rate law expression? Can you tell me what is the definition of a rate law expression? There are two laws that I have explained you. The one would be the law of mass action. The other one would be rate law expression. So what is rate law expression? Hello. 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 Hello.
Hello. Hello.
Am I audible?
Yes, but the screen has no.
The screen
Screen has not loaded info.
is not visible.
Yeah, now it's visible. It's okay. I can see.
I'm not able to hear you properly. Can you speak louder?
No, I can see now. I can see.
Now it is fine or not?
Yeah, it's fine. It's fine.
Hmm. Then tell me, what is the rate law expression? What is law of mass action? What is the difference between these two laws?
What difference between?
Hmm?
Difference between which laws?
What?
Difference between which laws did you ask?
The rate law expression and the law of mass action, the two laws.
The powers.
From the starting, what is the rate law expression? From the starting, how a rate law expression is defined? Have you written
Uh,
in your copy? Have you written it?
Not the whole definition. I already
Okay.
wrote the expression.
Okay, fine. See, basically, rate law expression is nothing but it is just the multiplications of the law. It is multiplication of the active masses. It is multiplication.
Yes.
According to it, it is the multiplication of the active masses raised to the power of raised to some power. It may and may not be equals to the stoichiometry. Raised to some power. And it may and may not be equals to the
Yes.
stoichiometry. This is what? This is the rate law expression. And what is a law of mass action? It is basically the according to it, it is the multiplication of the active masses of the reactant raised to the power of their stoichiometry. Here the condition is not there. It is defined that its power should be alpha and beta, or depends on the stoichiometry which is there respectively of the reactant. Fine.
Okay. Yeah. Fine.
Hmm. Then what is order? So basically order is the additions of the stoichiometry of the reactants which is there in the rate law
Yes.
expression, and it is the experimental concept. Why? Because the rate law expression is the experimental concept and we are adding the powers of the rate law expression, so it is also the experimental concept. It is experimental concept and it can be negative, zero, or fraction, and can exceed from 3. Infinite values are not possible. So see, basically there are 4 things. The first one is my law of mass action. This is the first thing. The second one is my rate law expression. The third one would be my molecularity. Molecularity. And the fourth one is my order. So if you see, there are 4 things. There are 4 things. There are 4 things. First, second, third, fourth. 4 things are there. And if you see, this is my theoretical concept or experimental concept. Law of mass action is theoretical or experimental? Tell me.
Experimental.
Acha, experimental. Can you tell me the definition of rate law action? Mass action. What is the definition of rate law of mass action?
It's based on stoichiometry.
It is what?
Based on stoichiometry, it's the multiplication of the.
Multiplication of
Mm,
what? Multiplication of what? Bolo bolo. Multiplications of the active masses. Simple.
active masses A
Or
and B, A and
multiplication,
B,
if you are not
raised to the
able
power
to
of.
recall the active mass, then it is multiplication of the reactant concentration of the reactants. The multiplications of the concentration of the reactant raised to the power of stoichiometry. So if the power is stoichiometry, it means that it is the theoretical concept. Why? Because the stoichiometry that you are defining in a reaction is basically a theoretical concept that this much amount is reacts with this much amount and this much amount is formed. So basically, this is the theoretical concept. If the stoichiometry is there, that means it is a theoretical concept. And if it is not depends on the stoichiometry,
Okay.
it will having some power. It means that it is the practical concept or the experimental concept. It depends upon the experiment. Depends upon how the conditions are there. Depends upon how the reaction will proceeds. So it depends. So if the thing depends on something, it is the variable thing. We do not know what is the power, what is the power which is associated with it. Then it means that it is basically then what I was telling you. Okay, then it means that it is a practical concept. Okay, so if the and the order is also associated with the rate law expression. It is rate law expression. Rate law expression is associated with the order. So if the order
Mm,
is associated with the rate law expression, it means that this is also the experimental concept. So it's very easy. You do not have to recall everything. You have to just connect the things accordingly. You are starting with the rate law mass action, then goes on to the molecularity, then move forward to the rate law expression, then move towards the order. So basically, order and rate law expression is connected through the raised to some power, and it means that it is the experimental concept. And again, the order and the molecularity is opposite of each other. Why? Because it can more than 3. It may be more than 3. It may, what is written here, it may be more than 3 and infinity value are not possible. Infinity is not possible, but it can more than 3. It can be fraction. It can be 0. It can be negative. It can be anything. But the molecularity is not anything.
yeah.
Molecularity is not 0. Molecularity is not in fraction. Molecularity is not in negative. Molecularity is not going to be exceed 3. So these are the things now. So this is what? This is the order of the reaction, just you have to add the order. So if I ask you what is the order with respect to A, then the power which is associated with the order in a rate law expression is the order of A or order of B, depends on the power which is associated with it. Understood? This is all about my,
Understood.
this is all about what?
Order of range.
Orders. Now this is the unit, the calculations of the unit. Unit of rate law, unit of
Right law.
R the constant, rate law constant, K. We are going to discuss about the units. So basically, let's say I'm having a reaction, A capital A gives you product. Okay. So this is basically the reactant. A is my reactant and small a is my coefficient which is associated with the reactant. So if I want to write a rate law expression, then how can I write a rate law expression? Basically, R is equals to A raised to the power of some power. Okay. But if I ask you ki the power is, let's say anything, let's say power is N. Let's say this power is N, because this not depends on A, na? Power is not depends on A. Why? Because I am writing the rate law expression, and in the rate law expression, it is not
Yeah.
mandatory that the power is A. It can be anything. So if I am writing here, let's take a variable N here. The power should be in the variable of N. Okay. So this is the order. The N is the order. If you see here, this N is the order of reaction, or if only one reactant is there, then I can also write that it is the order with respect to A. So if I want to write the unit of that, so you have to put the K at one side and other parts at another side. And if you see here, if you put the concentration to the, if you simplify everything, so if you want to simplify, basically, what is the unit of rate law? What is the unit of this R? Rate constant. So it is basically mole per second, and this is the concentration. This is the concentration. And if you again further simplify this, it may be mole per mole per volume per second. You can write this
Second.
as well. Okay. So if you
Yeah.
see here,
Okay.
if you see here carefully, what is written here is that this is the K divided by A ki power N, and N is anything, and this is mole per liter. Liter is the unit of volume. Mole per liter is your mole. Molar. Molar is basically more per liter.
Yes.
Understood? So this is written here to the power 1 and per second. So this is the
Yeah.
unit of R. Unit of R is written here, and this is the unit of concentration again. Concentration of the mole with the power N. Okay. So if I replace this mole per liter to M, then how can I define the rate? So if you see here, M
Mhm.
mole per second, it means that S ki power minus 1. This will having a power 1, and M power minus N. Are you understanding what I am written here? M is what? M is molarity.
Molar.
Molal.
Yeah.
So this is
Okay.
molarity per second. Molarity per second. This is the molarity to the power N. If you simplify this, if you put this in a denominator, then what will happen with N? It is going to be in negative. So if you write properly, then the unit of K is M1 minus N. Simple maths per second. So this is the this is the general formula. This is the general formula of unit of K. Understood or not? What is the thing that you
No,
have
could you
not able
repeat
to
the
uh,
last,
huh?
the last step?
See, okay, I'm again explaining you. See, just
Okay.
remove everything there from it. See, we are discussing about the unit of rate constant. We are discussing about unit of rate constant. Okay. Now, I know the form. I'm writing just rate law expression. I'm having a general chemical equation, simple, very simple chemical equation. A, this is alpha A, and this will form product. This is the simplest form of chemical reaction. Now, if I want to write a rate law expression, then this will be R equals to A to the power n, and this is what? This is the order of reaction. Understood? Now,
Yeah.
if I want to write a rate constant, the unit of K, then K I have to put the K at the RHS and everything at the LHS. Everything is clear at this point or not?
Yes, it is.
Bolo sir,
Yes, yes,
everything is clear or not at this
yes.
point? Is there any doubt what I have done here?
No, no, I understood.
So, what is the unit of R? Tell me, what is the unit of R?
Moles per second.
Moles per second. Moles per second or mole per second? Molal per second.
More per second.
Mole or molal? Molar per second or mole per second?
More.
Molar,
More.
not mole. Basically,
Okay.
it is the
Okay.
concentration to per second, change in concentration per second. And concentration should be in
Per
molar, na?
second.
Molecularity. Why mole?
Yeah, yeah.
If you want to write in
Okay.
moles, then you have to also write the term of liters, mole per second. This is the unit of molarity, mole per liter. And you can write the mole per liter as capital M, molar. Understood?
Understood.
Now, what is the unit of A here?
Same M.
A, this is the
Molar.
concentration now. So it is also M.
Molar. Molar, yeah.
Simple logic now, this is the concentration. That means it is also the
Yes,
molecule
yes. Molar, yes.
to the power N. Why? Because we are dealing with this. Is there any doubt? We do not know N because it's variable. It depends upon which type of reaction is it. Bolo yes or no? Respond me, then I can move forward. You have to respond me.
Yeah, yeah. I said yes. Yes.
So, is there any doubt at this point or not?
No, I understood. Understood.
Okay. So you have to put this mole to the power molar to the power n to the denominator. Then what will happen? This will happen minus n.
Yes.
If you want to write this k equals to r a ki power minus n. Is there any doubt? This is k r a ki power minus n. So I have just written the concentrate. This is written the unit of r, which is molar per second. Unit of n, which is the m to the power minus n. Is there any doubt here?
No doubt. I understood.
So just simplify it. M to the power 1 minus n, and this one should be in minus 1. This is the general generic generic formula for unit of k. Why I am writing the generic formula? Why the formula is not defined? What is the unit is? Why the unit is not defined for k as constant unit? Unit is defined, but why the unit of k is not constant? Because because the rate law expression having the concentration to the power n is variable. N is variable. So if n is variable, that means that the unit of k is also variable. It depends upon n. Which type of reaction is it? So if it is a zero order reaction, what do you mean by zero order reaction? Zero order reaction means that n is equals to 0. n is equals to 0, it means that it is a zero order reaction. Any reaction having a order as 0 is your zero order reaction. Understood or not? Like this
Understood.
is the reaction, and if n is equals to 0, it means that R is basically only depends on K. So R is equals to K. This is what? This is the type of a chemical reaction. And such type of reaction is known as zero order reaction. And if the value of n is equals to 1, then this will be first order reaction. If the value of n is equals to 2, then it is second order reaction. If the value of n is 3, it is third order reaction, fourth order
Yes.
reaction, fifth order reaction, sixth order reaction, seventh order, eighth order, nth order, nth order. It only depends on what is the value of n. As much as the value of n increases, the units of k is also depends on it. Understood or not? So if you see here,
Understood.
what is the unit of K when the order is zero order? For zero order reaction, n is equals to 0. It means that if you put the value of n as 0 here, so the order will be mole per second. It will be
Yes.
equals to the unit of R. So K is basically equals to R. So the unit of R is also equals to K.
Yes.
So it is molar per second is, see here, molar per second. Molar per second is the unit of K here. See,
Yes.
mole per liter per second. This is molar per second is the unit of K. Understood or not? If it
Understood.
is first order reaction, then you have to put here 1. So 1 minus 1 is 0. It means that
0.
m ki power 0 is your 1. It means that the unit of K is per second only. Understood or
Yes.
not? Are you getting my point?
Yeah, understood. Yeah, understood.
Okay. If you have any doubt, you can ask me right now.
No, I understood.
Everything?
Yes, this thing I understood.
Okay. So this is all about my rate of reaction. So now I'm giving you one question. Okay, you have to solve it. Then after I'll give you another question. Okay. The question is this. Just one second. The question is this. The question is this. This is the question. Okay, so let's discuss this question. What is it written? So A2 reacts with B2 gives 2AB. This is the reaction. If you see here, A2 is the concentration, B2 is the concentration, 0.2, 0.2, 0.4, 0.2, 0.4, 0.2. These are the concentration of A2, concentration of B2. And this is the rate of a reaction, which is written here. Okay, now if I want to write a rate law expression for this reaction, which is given, how can I write a rate of reaction? Rate law expression. I am writing the rate law expression solution. So the rate law expression of A2, B2 gives 2AB. Rate law expression. Rate law expression. So R is equals to K to the power A2, B2 to the power, let's say, alpha beta. Okay, and I do not know what is alpha, what is beta. I am not aware of alpha and beta. These are the variables. Why? Because it is a rate law expression. I have written rate law expression. And if we see here, all the reaction is balanced here. The reaction is balanced here. And I have put alpha and beta as the power of
Yes.
this stoichiometry because it is the rate law expression. Now how I have to find what? I have to find the rate law expression. I have to find the value of alpha, beta, order of reaction, unit of K. I have to find all these three things. So such type of questions can be asked in your exam. It is having a very high probability of it. Okay, so if you see here in the question wala part carefully, if you put the concentration, if you have to take two steps at one time. You have to observe two two steps at one time. You have to observe what? Two steps at one time.
Two
Okay.
steps.
So point 2 and point 2 is the concentration of A. It means that the concentration of A is not increasing. Means that the A is constant. A2 is constant. And what is happening with B2? The concentration is changing from point 2 to point 4. What is happening with the concentration of B2? Can you tell me?
It's going from 0.2
Huh?
to 0.4. It's going from 0.2 to 0.4.
Okay, so how many times B2 is changing?
0.2.
2 times. If you multiply here with 2, then this concentration will be point 0.4. Understood or not? If you multiply point 2 to 2, you'll get point 0.4. Is there any doubt in this or
Yes.
not?
Yes.
Bolo.
So that. Yes. Yes.
Okay. Now see, you are having rate of reaction. So this is the rate of reaction in first step, and this is the rate of reaction in the second step. This is the first step. This is the second step.
Second
How
step.
many times the rate of reaction is changing? How many times?
By 2.
Huh?
By 2. Multiply by 2.
2 times, na? If you multiply here with 2, you'll get this.
Yes.
If you multiply here 2, you'll get this. It means that, and what is happening is, if you changing the concentration, if you doubling the concentration of B2, then my rate is also doubling it. My rate is also increasing with 2
Double.
times. Its magnitude is increasing with 2 times. When I increase my concentration of B2 with 2 times. So
Yes.
basically, and A is constant here. If you see that A is constant, A is not changing. A is point 0.2 and point 0.2. A is not changing. What is the thing that is changing? B2 is changing from point 0.2 to point 0.4. And my rate is also changing according to the B. It means that I have to predict the power of beta. So if you see ki if I put uh, beta equals to 1, alpha equals to 0, this will happens. Why I am doing it? Beta equals to 1 and alpha equals to 0. Why it is there? Why? Because if you see here, कहाँ गया मेरा cursor? If you see here, this concentration is not bothering me in the change in the concentration of the reactant. If I change this one, so I can easily replace this with 1. So my final reaction would be beta to the power 1 equals to R. So this is what which is happening here. So if you multiply the concentration of beta with 2, this thing is also you have to multiply with 2 so that the reaction will be same. Both side, LHS side and RHS side. RHS, LHS, RHS. Are you getting my point? What I am trying to tell you? My A2 to the power equals to 0. Why? Can you tell me why?
Because there's no change in the
Yes.
A2.
So
That
this
remains
is
the
this is
same.
the first condition. This is not the answer. This is the
First
rate
condition.
expression according to the first observation. Now let's move on to the next observation. What is the next observation? What is the next
A2
observation? What
changes.
is the next observation? So the next observation you have to take 2 steps. This one. What is the step that you have to take? You have to take 2 steps. I am taking 2 steps. This and this. The step 1 and step 3. I am clubbing these 2 steps. Why I am not taking step 2?
Okay.
Because if you see here, point 2 to point 4, point 4 to point 2 means that both are changing. If both the variables are changing, then it will very difficult to predict the answer. So you have to put one variable
Okay.
as constant and the other one as variable. Okay, so you have to put one
Okay.
step as constant. So initially what I have done, initially I have taken the 2 steps in which my A is constant. But in the next step, what I have taken is that my A is changing, B is constant. Point 2 and point 2 is same for my B. See,
Yes, I can see.
Now, what is happening? If my b is constant, I'm not, considering this by, because b is constant. I am neglecting b here. If you see point 0.2 to point 0.4, how much change is there? Point 0.2 to point 0.4, how much change is there? How
By
many
two.
times it is? Point 0.4 is
Two.
bigger than point 0.2. How many times?
Two times.
Two times. It means that if I multiply the reactant, to 2, then my rate will changes from 3 to 4. So how many times the rate is changing?
Four times.
4 times. It means that if I multiply the concentration with if I multiply the concentration of A with 2, my rate will be changes to 4 times. It means that 2 to the power 2 times. 2 to the power 2 times. My rate is changing to 4 times. It means that 2 to the power 2 times. Understood?
Yes. Yeah, understood.
If I'm changing the concentration to 2 times, then the rate is changing to 4 times. So if you see here, what I have to take here, then
Two is
according to
four
this,
times. Yeah.
the rate law would be R K and alpha 2 to the power 2. This is the rate law expression that I have get from the second condition. This is the first condition, this is the second condition. So the value of alpha would be 2. Why? Because if I multiply this by 2 here, then my rate would be changes to 4 times. Why? 2 to the power 2, 2 to the power 2 is 4. So if you see here, 4 will comes up here. It means that if you change the concentration with 2 times, my rate will be changes to 4 times. So this will be practically happens when this thing will happen. The alpha would be 2. If the alpha would be 2, such thing will happens. Understood or not?
Yeah.
Correct?
Two.
Are you getting my point? So if you club these two conditions, what is the value of alpha and beta? If you club these two conditions, what is the value of alpha and
Yes.
beta? The value of alpha is 2. Value of beta that I have calculated in the first step would be 1.
One.
So
Yeah.
you can easily write the rate law expression. So the rate law expression would be, R would be
Two.
K A2 to the power alpha B2 to the power beta, R equals to K A alpha equals to 2, beta equals to 1. So this is the rate law expression. If I want to know the order, then the
Yes.
order will be 2 plus 1. The order will be 3. The order will be 3.
Three.
The order will be
Yes.
3. Rate law expression is this. Okay, and unit of K. So if the order is 3, third order reaction is this. It means that if you want the unit of K, the formula is 1 minus m to the power 1 minus n, s to the power minus n. So if you put 3 here, then the formula would be minus 2 per second. So this is the unit of K, because it is the third order reaction. Why? Because the order is 3 here.
Yeah.
Are you getting my point or not?
Yeah. Yeah, understood.
So how I have solved this question, you have to tell me the procedure from the starting. Tell me first what I have done first, and tell me the reason why I have done this one. Tell me what I have done in order to find
Uh,
the answers.
First, you wrote the rate of law expression.
Firstly, I have write the rate law expression in a generic form. Then
Yes.
after I want the value of alpha and beta. For that, what I have
Yes.
done, I have taken
The
two conditions. If in the first
first two.
condition would be my one concentration is constant and the other concentration is changing. So if you see that
Yes.
my other concentration is changing by 2 times, so if you see to the rate of reaction, again my rate of reaction is changing to 2 times. So the change is same. If the change is same, it means that the power is 1. The beta having the power
Yes.
is 1, and it
One.
is not depending on alpha. Y, because alpha is constant. And now in the second condition, if my beta is constant, point 2 and point 2, beta, I have taken beta as constant and alpha is changing now. So if you see alpha is changing, it means that my rate is changing to 4 times. If the change in
Yes.
alpha, if the change in A is 2, if the change in A2 is 2 times, then I see that the change in my rate of reaction is 4 times. So
Four
the
times.
power of A2 would be 2. So if I
Yes.
club these two conditions, I'll get this one. What? Alpha equals to 2, beta equals to 1. If I add these two powers, I'll get the rate of I'll get the order, which is 3. And through 3, I can
Order of
easily get
wave.
the unit of K, and I can easily write the rate law
Unit of
expression.
K.
But this is not the way that you have to present the answer in the examination. This is not the way. This is the short trick. This is the short trick. You do not have to write all these things. If the
Okay.
question is MCQ type question, then you do not have to write all these things. Just you have to think in your mind. How you have to think in your mind? The procedure of thinking is that you have to put one concentration constant and the other concentration is changing, and just observe the rate, how
Changing.
the rate is changing. So see, if I want to solve this
Okay.
question in my mind, then what are the procedures? The first one is I have to take these two as a constant. That means just forget this, and this one is changing to 2 times, and this one is changing to 2 times. It means that my beta equals to 1. Simple. And if I take this one is changing, this second condition, this one is changing, and this one is constant. These two things are constant. Then I have to neglect this one. I have to take this one. So if the change is 2 times in this part and the change is 4 times in this part, it means that to the power 2. It means that what? A2 having the power 2. That's it. The question is solved here. Then you have to just put the values and this I answer. But this is not the way that you have to write the answer in the exam. That is not the procedure. Okay.
Okay.
So now I
Okay.
am going to tell you the procedure in the next page. So the procedure is, see the procedure.
Yes.
Okay. What is the procedure? So procedure. एक सेकेंड प्रोसेस ये लिख देता हूँ प्रोसेस सो इन बोर्ड्स कैसे प्रेजेंट करना है आंसर बोर्ड्स में आंसर कैसे प्रेजेंट करो सो यू हैव टू राइट आंसर हाउ फर्स्ट you have to write the given part which is given to you. So these are the things which is the thing which is given to you is the table A2 plus B2 gives you, this is the reaction which is given to you, and the next thing that is given to you is the table, and you do not need to write the table because it is there in your exam paper. Just you have to write the given part, and according to rate law expression, according to, you have to write the according to rate law expression, you have to write this in completely. You have to write the rate law expression here. R is equals to K, A to the power alpha, B to the power beta. Okay, this is you have to write. Now you have to find. You have to write what you need to find, alpha and beta. So for that, just take first step. Just write first step. What is the first step? You have to write everything in this formula with respect to this. So what is the value of A2 in this first step? What is the value of A2 in the first step? This is the first step, this is the second step, this is the third step. What is the value of A2? 0.2. So the value of A2 is
Yes.
0.2. So you have to write here 0.2 to the power alpha. Got it? 0.2 to the power alpha multiply by B2. What is the concentration of B2? 0.2 to the power beta gives the multiply by K equals to what? The rate. 3 multiplied by 10 to the power minus 2. This is the first step. Now, this is the first, mark this one as a reaction one first. Now the second step. Second step again, take this A2 as 0.2 to the power alpha. Just put the values which is there in this formula. Hello, Elisha.
Yeah.
What I am
Yeah.
trying to say is that you just put all the values in this expression. That's it. 0.4
Yes.
to the power beta. And what is the rate now? 6 multiplied by 10 to the power minus 2. This is the second condition. Now, for the third condition, for the third, For the third, you have to write 0.4 to the power alpha, 0.2 to the power beta, multiply by k, and equals to 12 multiplied by 10 to the power minus 2. This is the third thing. This is second, this is third. Got it? Got it, everything?
Yeah.
Now, you have three reactions and you have to solve this question. So what you need to do is that just take two reactions for the first. So I'm just taking two reactions, okay? Just taking the one in which these two things are constant. So if you see there, 0.2 alpha is constant, 0.2 alpha is constant. So I'm taking 1 and 2. I'm just dividing reaction 1 and 2. What I'm doing is that I'm just dividing. You have to write. I'm dividing 0.1 and 0.2. You have to write it. Okay, here. So 0.2 to the power alpha, 0.2 to the power beta equals to 3 into 10 to the power minus 2 divided by 0.2 to the power alpha, 0.4 to the power beta equals to 6 multiplied by 10 to the power minus 2. Okay. Now 0.2 alpha cancel out. K and K is going to be cancelled out because it is same, because the reaction is the same. Reaction is same, that means constant is same. And now this point 10 to the power minus 2, 10 to the power minus 2 cancel out. 1 and 2, this will cancel out. So you'll get in, at last you'll get 0.2 divided by 0.4 to the power beta equals to 1 by 2. Are you getting my point? This thing you are getting at last.
Yes.
Now, then this is very easy. Now you have to solve for the beta. Okay, so this one would be 1 and this one would be 2. This will comes up to half. Then what is the power of half so that my answer would be half?
Yeah,
What is the
1.
power of a half so that my answer would be half? Tell me. What is the power? What is the value of beta here so that my answer will be half? Fast?
1.
1. Very simple. So we'll get the beta. Now do the same thing. Do the same thing for reaction 1 and reaction 3. Same thing. Why? Because now beta is going to be cancelled out. See, for the second, for the second, for the second part, that would be, I'm just dividing first reaction with third reaction. The first reaction is 0.2 alpha, 0.2 beta equals to 3 into 10 to the power minus 2. And I'm dividing it with 0.4 alpha, 0.2 beta multiplied by k equals to 12 multiplied by 10 to the power minus 2. So if you see here, what is cancel out? What is, so 0.2 beta, 0.2 beta cancel out, k and k cancel out, 10 to the power minus 2, 10 to the power minus 2 cancel out. And if you see 0.2 divided by 0.4 to the power alpha is equals to 3 to by 12. So you'll get 1 upon 2, 1 upon 2 to the power alpha, 1 upon 2 to the power alpha equals to 1 by 4. So what is the
4.
power of alpha so that my answer would be 1 by 4? Tell me.
2.
That's it. The answer is 2.
Yeah.
So you'll get the value as alpha of alpha is 2. So what is the order of reaction? Order is 1
3.
plus 2. That will be equals to 3. What is the unit of k? M 1 minus n s minus 1. So unit of k would be 1 minus 3 minus 1. So that would be m minus 2 s minus 1. This is the unit of k. If you want to write in
Yes.
expanded form, just open the mole per liter to the power minus 2 per second. That's it. And what is the rate law expression? Rate law expression is R K A2 to the power 2 B2 to the power 1. That's it. Everything is answered. Okay, so this is the procedure that
Yes.
you have to follow in your exam. And this is the thing that you have to follow if the question is MCQ type. Okay, so I have told you the procedure of solving questions accordingly, whether the question is MCQ type or other. Okay, so we are done with
Okay.
the your molecularity and order. In the next class, we are going to discuss about first order reaction, second order reaction, and nth order reaction. And in I think 2 classes, we are going to complete this chapter. In the next 2 class, we are going next week we are going to complete this chapter. Okay.
Okay.
Yes. So this is all about for this class. If you have any doubt, you can ask me or not, then you may leave.
Um, could you tell me which of them was theoretical and which was experimental?
Can you speak loud? I'm not able to hear properly.
Which expressions were theoretical and which was experimental?
This thing
Could
you
you
have to tell.
repeat that?
Theoretical is depending upon key. If I initially
Hmm.
classify anything that the power is based on the stoichiometry. Like for example, if I given you the chemical reaction and you just you just what you just balance the chemical reaction, and after you have balanced the chemical reaction, then I'll ask you just write the law of mass action. Then how you just write the law of mass action? You just write the formula R is equals to K, multiply the concentrations of the reactant to the power of the stoichiometry which is there. So if initially everything is predefined, like you are writing the power which is there in the stoichiometry, then this is the theoretical concept, because this is the thing that you have solved in the exam. This is the thing that you have solved in the paper. You have not performed any
Okay.
experiment. You have done you do not do anything in the lab. You just solve to the with the help of the maths, and just write the expression law of mass law of mass action as R is equals to K, a to the power of something, a to the power of, let's say, alpha, and b to the power of beta, and alpha and beta are the stoichiometric, which is respect with the respective to the reactants. So this is the theoretical concept. But
Okay.
but but what is the experimental concept? This is the experimental concept. This question is the experimental concept. Why? If I want to write the order of the reaction, then I can easily write the order of reaction. Why I am doing such things? Why I am doing falana dimkana? I just write here ki R is equals to K multiplied by A2 ki power 1, B2 ki power 1. Why? Because stoichiometry is 1. See, so this is the law of mass action. This is law of mass action. This is not
Okay.
the rate law expression. Okay, this is not the correct thing. But if I ask you ki this, if I tell you I have performed the experiment in the lab and I have noted the reading, if I am having zero point 0.2 gram of my A2 and zero point 0.2 gram of my B2, then the rate would be this and the rate would be this. And the if I took zero point 0.4 gram of my A2 and zero point 0.2 gram of my B2, then the rate is this. Then after calculating in such way like this, after the observation, then I'll do some calculations based on the observation. And then I'll get the values at beta equals to 1 and alpha equals to 2. So this is the experimental concept. And basically the order is experimental. Molecularity is not experimental. If I ask you what is the molecularity of the reaction, the molecularity would be 2. Molecularity would be 2. See? And this is how
Two.
1 and
Yeah.
1 equals 2. Wherein 1, if I add 1 plus 1, it will be 2. And this is the law of mass action, not law of rate law expression. This is not the rate law expression. This is law of mass action. And the
Yeah.
molecularity is to 1 plus 1 is equals to 2. So this is the difference between experimental and your. And the question that will ask in the examination is based on differentiate between molecularity, differentiate between your order, differentiate between your law of mass action, differentiate between your rate law expression. So such type of questions is going to be asked in the examination. You just have to solve all the questions that I have given you in the class. That's it. Okay. Everything that I am,
Okay.
solving in the class
Okay.
is enough, more than enough for any exam, like at the board level. Any exam at the board level is, very simple. Every content that I'm giving you is sufficient. The questions, the type of questions I am, explaining you, giving you, illustrating you is sufficient, more than sufficient. You just have to solve again, once again, so that it is easy for you to recall the concept or get the concept properly into your hand. Okay, fine.
Okay.
Okay.
Fine.
Okay. So that's it for today's class. Okay. Bye.
Okay. Thank you.